everyone. In this episode we will talk about not panic and not result, because we already introduced panic and result in the previous videos, but I want to talk more about when we should use panic and when we should use result or not the panic macro in Rust. We introduced error handling a couple of lessons ago, so let's see in details which are the use cases. When should we use panic and when we should not use it? Just a quick recap. Panic, you can see this here on the left, indicates an unrecoverable error, and results, you can see this on the right, allows to handle the error in a more, let's say, graceful way. It's similar to the concept of exceptions. So you can see here an example on the left and an example on the right. You can see here this OK error here, and then in here, for example, you can see the panic macro. So when should we use the panic macro? The panic macro. There are some use cases. One is in some examples, or when, for example, we want to show some simple code. When we are prototyping some, when we are doing a prototype of a bigger application, but we want just to get started. For tests, this is a spoiler, we will see this, and also when the code ends in a very unexpected way. In this case, we want to intentionally the code basically to just end. In this case, we want the program to stop and not continue. And also, this is interesting when we have more information about the code rather than the compiler for some human logic that we are applying here. But let's see this one by one. So let's say that we want to show an example in Rust. What we can do is that we can intentionally call the panic macro. We can see here on line 12. So we can call it intentionally as programmers, but to be honest, in one example here we are calling, for example, here we want to access an index in a vector that doesn't exist. You can see here a vector with 3 elements, and we want to access the element on position 11, because we are indexing the position number 10 and we start counting from 0. In this case, we will have an error anyway, a panic anyway, but we can also call this intentionally. Another use case is when we have some prototype code. So we are just, getting started, in writing our Rust program. In this case, we can use unwrap and expect. You can check the previous video when I explain what unwrap and expect are. To be quick, a quick recap is that unwrap basically calls the panic function, and the expect also calls the panic macro, but with a string. You can see here on line 11 on the example below that we basically return a specific message. So expect gives, let's say, a bit of error handling, but still the code, the program panics. So this is useful because let's say that in the future we want to add a more useful error handling, but for now, at least we want to start to put a sort of placeholder for when we'll come back and we'll handle this error more properly. Another use case for panic is for test. This is a huge spoiler because we didn't see test in Rust yet. Tests, I think, in Rust are very, very convenient compared to other programming languages. But let's say that we want to test our code. Okay, you don't have to understand everything here, but this is a test for code. In case the test fails, we want the whole code to panic. You can see here on line 11. So this is another use case of the panic macro. So in this case, we should absolutely panic, because here we are not handling the error, but we are testing our code. And another use case for panic is when we have something very strange, an unexpected state. For example, here, let's say that we want to panic in case we get a temperature which is lower than 273 Celsius degrees. We know that this is not physically possible as far as we know in 2024. And let's pretend that this number has not been passed by a user, but maybe, I don't know, by a sensor, by another program. And in this case, we want the program to panic. Something bad really happened here. This is not what should happen. So in this case, we might want to intentionally panic the code. Check line 8. Temperature is below absolute zero. This is not physically possible. Another case where we can use the panic macro is that we know something about the code that the compiler does not. Okay, let's see this example. Check line 1, we define an hard-coded IP address, and then on line 2, we want to just use it. Okay, imagine a code which is, of course, more complicated than this. So in case we have an error here, we can return a message using the expect method. Hey, we should have the IP here because we just hard-coded it. So this is a custom message for us or other developers that informs the developer of a very strange behavior. Another use case might be that we are reading from a configuration file and we know that this configuration file should be there. So if the configuration file is not there, probably something happened, I don't know, in the deployment, or I don't know, it has been deleted by someone. So in those cases, we want probably the code to stop executing. I remind you that the panic mode in Rust is a way to just stop executing everything and start clearing the stack and all the memory, because we don't want the user to access random blocks in memory, because this can lead to some security issues. And now let's see when can we use result. Result is used to handle errors. So we want to handle errors when we have an expected failure. Clear use case is when we have HTTP requests. We have like HTTP codes for 200, 300, 400, and this is absolutely normal because we know that when we make some HTTP request, something might go wrong, and this is fine. So this is to handle the failure in this case. And another use case is when we want the code to be more flexible. We decide that we want to handle the error and not just the program stop executing. We will see now some example scenarios. One is that, for example, when we get an input from the user which is not what we expect. Let's say that we expect a number and we get a string. Or for example, if we want to handle some rate limiting in an HTTP request, we will see an example in some seconds. And also, and this is very interesting, is when we want a custom error type. We can create a custom error types in Rust. I want to stop. Russian, how are you? I'm still learning references in Rust, but your crash course, but it feels like your live events are much more interesting. Yes, Nebora, if you... Nebox, sorry. I do live events because you can ask questions just right after this. But of course, if you don't have time, you can catch up them. I highly recommend to check them all, of course, because also now I will make some references to the old lessons. It starts to be very hot here. Okay. Okay. Join X, just taking a break. This is the first video, then we'll make a break, and then we'll record the second video, and then we'll relax. Okay? So let's go here. Okay. Okay. No. Okay. For example, let's say that we want to handle some parsing errors. Check the line 2 here. We get a user input instead of we expect a number, and the user, intentionally or not intentionally, they type 42A. This is not a number, of course. So in this case, we can have a function. You can see this on line 10 to parse the number, and you see that we get in input a string, which is an input type, and then we get a result in output here. Check the signature here in the function, and then we trim this input, and then we parse to try to read a number. And in this case we can have an OK, and in this case we return the number, otherwise we'll return this error. And then we use this parse number function here on line 4 with another match statement. And in this case, you see, we handle the error. And for example, here we can simply just ask the input again to the user, so we don't have to stop the execution of our program because our user did something strange. Okay? Okay. Viresh expecting Rust crash course with small mini projects. No worries, we'll have it, but I want to really cover all the basics. We will have some Rust projects coming up soon. I did a good one, but I need to find the time to record it. But I want to do a complete Rust and free tutorial. This is what I want to do now. Another example might be when we want to handle, let's say, rate limiting in HTTP requests. So let's say that we want to fetch some data, but in case we fail, we don't want just to stop trying, but we want to try at least 3 times. Check here on line, we don't have the line here, but check it here. Check it here. We have, in case we fetch data and is okay, we get the response. Otherwise, in case we have an error, we try 3 more times. Check here. In case we have this error here, this is rate limited, and we retry after 1 second. You see, we are handling the error, and in case we fail for 3 times, maybe, I don't know, we have network issues and so on, then we return the specific error. Okay, so we have this snippet that demonstrates how we can handle this rate limiting in HTTP using the result type. You see here the result. We are returning the result. We'll talk about the result type soon when we introduce the generics in the next lesson. Another great use case for error handling is that we can create some custom types. I think this is very interesting and very powerful. Let's say that we want to make a guess number game in Rust, and we want the user to just input a value which is between 1 and 100, and of course it has to be a number. So check it here. We have this struct, which is just a guess with a value i32, but check here the implementation of the struct. If you want, there is a video about structs. So this is the implementation of methods for the guess struct. And basically on the constructor, we see here the new, we see that if the value is lower than 1 or bigger than 100, we return an error. And check the output of this function. This is a result which is a guess in case we get a number between 1 and 100, or a string. Why a string? Because we want to return the error type. Okay. Let's see. Okay. You know how this you will. Maybe know how this you will still. I will go and do it all. Okay. And we can see here on line 20 and 25, if we try the guess with the number 50, this is validated. Otherwise, we'll return an error on line 27 if we try to create a guess number which is above 100. Okay, so this is how we can create custom types for error handling in Rust. Let's make a quick summary. So the key points are that you can use the panic macro for unrecoverable errors and the program will stop executing, or we can return the result type if we want to manage these errors. This is very similar to the exceptions way of coding in other programming languages, for example Java. We can use the Rust type system for validation, of course, and we can create, as we did some seconds ago, some custom types to encapsulate the validation of other types or other functions logic. And this is the end of the first video. Now we'll take a break and then we'll record the second video. I'll stop recording. I need to remember to record and I'll be back. And then we have this, Ctrl P. Maybe we can put this for a while. If you have any questions or if we have... Virish, are you already advanced in Rust? It's very good for you if you're already advanced. It's very hot here. Okay. Test. I'm recording it. It's a bit low, I think. Test. It's the opposite. So basically now I'll check the live more. Basically I'm recording the videos. No water. I already forgot what I said. Yeah. The thing is that I really want everyone to be at the same level and really because I think that the Rust is not a simple programming language, so you really need the basics, the structs, data types, error handling. But if you're already advanced, you can check. I have a full stack video I can show you. I have a full stack CRUD API, full stack. Let's see if I am Rust and Docker. Let's see if my video is here. Yes, you see. I have videos on the first page of Google. This is one, for example. If you want something more advanced, you can check this. Also, all the code is available on GitHub. So you can share, copy. This has 200,000 views, which is nice. So if you want something more advanced, you can check this. Okay, here I do a full web server in Rust without using any framework. So I use a lot of the logic that I'm now explaining, but too many videos we don't got interested while learning. Any programming languages be like crash course with mini projects. The projects will come, no worries. The projects will come. I currently have a project in Rust, but I think it's very important to understand the logic. So that's it. That's the style and the style that people are liking for now. The problem is that if I just do mini projects, like I don't know, I have a generics lesson now. Then if I have a generics, you don't have the generic lesson reference. Hold on, please don't move to project. You see, you can't make everyone happy. I decided to go more on the basics. I agree with Neboxo in this case, but I have some projects. If you check my GitHub repository, I have many projects already. But I really want everyone to. The goal is to have a free Rust series on YouTube. So it's not a paid Rust course, I want this to be free so everyone can learn. That's my goal. I don't know if I'm doing it wrong. Probably I should do a paid course, but I want this really to be free for everyone. So that's my goal, Virash. Okay, but your hard work or any topic. Yes, it can be hard, but you will see, because I see the big picture. I see where this is going. So I want that when we will do more projects, more examples, I can put in the description of the video the explanation to all the things that I'm mentioning. Otherwise, basically I do just something which is mid-level. I want to do the basic stuff first. It's okay, Nevox, it's okay. Let's say that we make examples using error handling next month, in 2 months. I want to say, hey, I have these lessons about error handling, you can check them out. So I'm building the fundamentals of all the Rust content that will be on this channel, okay? I hope this is clear. I know that it can sound boring, I agree with you, but this is how you learn the things, from the basics, and then you pile up. You can't just, I don't want to do just random Rust videos. I want to go in order and do everything. This is what I want to do. I'm probably wrong, but we'll see. We'll see if I'm right or wrong. Okay. Nice. Perfect. Okay. I want... it's very hot here. We need to learn the basics, to me. Multi-cloud tutorials. I probably started doing some you mean multi-cloud? What do you mean? Just Azure, AWS? I did some videos about AWS and Azure in the past. More of them will come, but I'm waiting for important news. So if I get that news, you will see more cloud videos. Are you passionate about cloud? Do you have experience with Docker and Kubernetes? Or you just want to learn multi-cloud? Okay. Let's see. I think it's better to focus on fewer things. Until and unless concept is clear, projects aren't good. I agree with you. I agree. And you know what? Rust is not that old, so there is not much Rust content on YouTube. So I want to start from the basics, because I don't want other people to just do the basics instead of me, and then I do just a couple of random mini projects. No, I want to build from the basics. We are building a Rust castle, I would say. You will see. I've been posting Rust videos since January, so we are close to 6 months of posting. So, today we'll introduce generics. So we are going, let's say, I don't want to say super fast, but let's say generics is not a basic concept. I don't know if you already know about generics. In this case, you can type it down. When will it end? This is serious. I think we are close to the half of it. So we need to cover many topics, but we are on the right track. We posted a lot. And of course, my time is not unlimited, like everyone else. So now I am doing this one of these every week. I can show you this. Let's see if I find it. 1 second. One word of replace Java. Okay, 1 moment. I'll show you. So this is the playlist. One word. Hey Jatin, how are you? One word on future of Rust. We need to replace Java, Python, Golang. I think that no, all the programs are here. They are gonna stay. What I can say is that Rust is a loved programming language, and it will have some good use cases in the future. It's a powerful programming language. When a programming language is powerful, like C, C++, they will never die because they will always be interesting for someone. So we will see in the future if this will absolutely take over or not. For example, you mentioned Python here. Python was not that famous like 15 years ago. It exploded, but I think Python has been created in 1995, I'm not sure. It exploded in around 2010, 2008, so 15 years ago. Before it was not so uncommon. So my bet here is that Rust in 2, 3, 4 years will explode. And then I would have been like doing Rust for, like, I jumped on the train earlier. So if you want to jump on the train earlier with me, you can check these videos now, because maybe in 3 years, many more people will learn Rust, and maybe you will have an advantage based on respect to the people. So that's it. Okay, I think that we can go and do one more lesson. By the way, this is the last tutorial. We have 23 lessons so far, and you see we are covering everything: hello world, variables, data types, functions, control flow, ownership, references, slice, structs, methods, enums. I talked about Rust now, and then the match statement, if, let, packages, cargo, paths, modules, use keyword, collections, vectors, hash maps. So many topics. So that's thing. Okay, I think that we can go and finish this one. Let's go here. Let's get this. Jatin, how are you? So let's record the second video and then we can wrap up. Let's see. 1 second. Okay, so let's put this here. By the way, I can still see the chat. Let's see. Me and my friend trying to build something from Rust, basically open source terminal compared to warp.dev, and it will be Tokyo and async and Rust. Okay. Yeah, I'm currently not interested because I'm already doing a lot of stuff. Your last year model. Yeah, you can't post links. This is a anti-spam method. But yeah, good luck. Yes, Tokyo. I think I used Tokyo in some projects. Let's go. Yeah, of course. We can't have think about people spamming like porn links. we really can't have it. So that's it. We can close this. We can remove this one. Let's go. No worries. It happens. It's okay. So let's go here. Let's start recording again. And now we'll talk about generics. I'm excited. Okay, I will say welcome again because this will be another video. So this will be out in 2 weeks on not next Tuesday, but in 2 Tuesdays, because on Thursday I go to India and I'll be back on Monday the 1st of July. So this will be out on the 2nd of July. Okay, let's start. Let's wait a couple more seconds and then we start. 1 second. Let's see. Okay, that's it. Perfect. Let's go. Welcome everyone. Today we'll start talking about generics, traits and lifetimes in Rust. Maybe some of you already heard these terms, or at least the generic terms, so let's try to clarify what these terms are for the Rust programming languages, and let's see. what's the goal of generics, traits, and lifetimes? The goal is just one. We want to avoid code duplication. Check the code here on the left and check the code here on the right. For example, we want a function that finds the largest integer in a slice. And then we also want a function that finds the largest character in a slice. You see, the logic is similar, but we have a different type. So we can implement a way to have a single function that takes a generic type. And of course, generics maybe are a bit, maybe generics are not that easy to understand at the beginning, but of course they are very powerful. The generics allow to use and write flexible and reusable functions and types, using different types without sacrificing the performance of our code. We will see at the end an example. We will see an example at the end of a swap function, which has, you see, this T. This means generic, and it has some generics inputs. For example, let's say that we want to swap either strings or numbers, but the concept of swapping, it's a more abstract concept, I would say. Before we keep going, we already saw generics in this course at least 4 times, probably even more. We saw this when we introduced the option. I remind you that we don't have null in Rust, so this is handled by this option T, because this can be anything or none. When we introduced the vector collections, we can have a vector of characters, a vector of numbers, so this has a generic type. When we introduced the hash maps with key value pairs, this is why you see key V. By the way, this is not mandatory, this T, but this is a more convention. For example, hash map, we can have an hash map of strings and integers, like key value pairs. And check this out, result. We saw this in the previous video about error handling. We have a result with TE, because we can have anything here. Usually this is what we would like to have, or an error here, which can be a string or something else. Okay? No, I'm not staying here for a week, but this video will be out in 2 weeks. Let's talk about traits. And this might sound new as a term, but what if I tell you interfaces? Maybe more people are familiar with the term of interface in many other programming languages, for example, Java. So this is used to indicate an abstract behavior of something. You can see here at the top, we can define this trait with the trait keyword, I like it, and then we can use this trait when we implement a method in a struct. If you're not understanding this, please check the struct videos and methods. You can see here on line 5, let's say that we want, for example, summarize something, but we want to summarize both a news article or a tweet. Check line 5 and 16. So the concept of summarizing is the same, but maybe the struct of a news article and a tweet, they have different values. For example, for news articles, we have headline and content. For a tweet, we have username and content. Probably now this should be called post or X. But we have, for example, we want here to implement the trait in the method of the struct here. Check line 10 is very important. Implement summary, which is basically this sort of interface for news article. And this is how we implement the summary for the news article. And check line 21, we implement a summary for the tweet. And in this case, you see that we have a self-username and self-content. Instead, for the news article, we have check line 12 format, self-headline, self-content. And then we can use summarize both for a news article and a tweet, which is, I think, very, very, very convenient. And so basically we can create instances of news articles and tweets, and then we can summarize them. And traits are very useful because of the abstraction. They can be reusable, and we are applying basically here the concept of polymorphism. So we can enable functions to operate on any type that implements that trait. I will teach Tokyo, not today, but we will get into frameworks at some point. For now I used Actix, Rocket, Diesel as a ORM, and Tokyo. I want to say something. We will have a specific lesson about traits. So this is just an introduction. Let's see also an introduction to lifetime. So we'll have a specific lesson, but just let's try to grasp the concept here. Let's check the code here. It's not very easy to understand, but focus on line 1 here. So the lifetimes, they ensure that the references are valid for as long as they are needed, and this is to avoid dangling references in Rust. If you are not getting what I'm saying, check references, borrowing, and ownership in Rust in the previous videos. So let's focus for a moment for this with this syntax, and let's try to digest it. So we see this fn longest. Basically, we want the longest string here. We are getting this tick a, which specify this generic lifetime parameter, and then we have two parameters that also have the lifetime tick a. So x, this is a reference to a lifetime of type string here, both for x and y. And we see that as a return type, this is a string slice that lives at least as long as the lifetime tick a. So this is to avoid to having a dangling reference when we are calling this function. This is a more advanced concept, but this is just to have an idea that this is basically to avoid code duplication and to ensure that the references are still valid when they are needed. Struct are easy until we meet enums. I also have videos on enums. Let's check. Enums Rust videos. Di qua, qui, here. Okay, so first page of Google. So enums in Rust, 15 minutes. You can also check Primeagen. Rust enums are better, but this is just, I think, I don't know if it's explaining. This is more comparing Rust enums to the TypeScript enums. But I did something like enums for Rust. So this is the enums. You can check it out. You see why I like making these videos, because now you mention enums and I can send you the enums video. Coding gimmick here for the traits. I shared your stream on Twitter. Thank you. It's great. It's so hot today. I have an idea how hot it is today. Really, really hot today. Okay. So so you are Shubra. There is a Shubra who presented this. Perfect. Okay, nice. The sun is burning over here. I'm leaving the party. No, I'm burning because of all the lights here. Okay, let's go back here. We are almost done. Yeah, I'm Subra. Also, have you been running or you just... No, I've also been running, but this morning. When usually I go running in a very early morning, otherwise I will just disappear. But yes, James. Okay. Let's finish recording this episode so then we can move on. So again, generics So again, generics, traits, and lifetimes are used to avoid code duplication. For example, here we have two blocks to swap two elements of the same type, but check how much code we have to type here. We have to use an additional variable, a temporary variable, then we have to say a equal b equal temp. So this is a lot of work, and you check again. We need to do this again when we have two strings, and this takes some code duplication. And I mean, code duplication is not necessarily bad, but the code is less maintainable. When I want to make some changes, I need to apply these changes to all the parts, and this usually introduces some errors. Hey Warlord, share the link of Cloud. Just it's a playlist, DevOps and Docker. Okay. Let's see an example of generics. If you have ever used generics, type it in the comments and tell me also in which language you used generics. I use them in Java, for example. So, for example, here, let's check this one. So, compared to the previous one, we import the replace function. I made a specific video about this use keyword, and we import this standard library memory replace, and check line 5, very important, function swap t, which takes two inputs of a generic type, and check how simple this function is. This is exactly what we want. Basically we define this temporary variable, and then we replace x with y with this syntax. It's basically one line of code. And this is powerful because we can do this both for numbers and also strings. If you want, I can also give you this code, but this is exactly what we want. And so once we have this, let's say that in the future, I don't know, we have another type, we can swap types. I think this also works with different and more complicated types, like I think even vectors or even structs. I should test it out, but at least with numbers and strings, this does work. I also did without the third variable. Yeah, that's fine. Okay. Same swap code I did a few weeks back on C++. I don't know if in Rust you do this without, but I mean it does. Here I'm using the replace function inside the standard library. You have to use pointers probably. Yes. Yes, exactly. And you see here in the syntax, of course, we use a reference. This is for people who, of course, already have coded in Rust, because we don't want to take ownership of the variable in input, but we want just a reference to that value to being able to swap the two variables, because otherwise this will have some errors. Something, let's say, I don't want to say easy, but let's say swapping two variables should not be that complicated, and in this case using generics is an example. Let's make a quick summary, a quick recap. So the generics are used to write flexible and reusable code using some placeholder for the type. Usually is T, it can also be K, V, for example, for hash maps, but the idea is that we want some code that works for different types. And there are in some cases, this can be very, very useful. Traits, you can read this as interfaces, even if they are not exactly the same. We will make a specific lesson about traits, no worries. And the idea is to define a shared abstract behavior between some implementations. We saw an example some minutes ago. And the lifetimes are used to be sure that we have a reference which is still valid and to prevent dangling references when we are using some other variables in our code. We are getting into concepts that are not that basic anymore, so so we are starting to use something more powerful, and of course soon we will be able to do something which is more cool.